Welcome back. Let's now check if our ODE is linear or not. Suppose that the solution for this case is this one, and the solution for this case is this one. Inserting them in the respective ODEs, I will have this result for the first case. I can also rewrite it like this, and that would equal F1. Then this would be the second case that I can rewrite like this, and that would equal F2. Then I will add the two solutions up, and I will insert this new solution into my ODE. I will have m times all this plus c times all this plus k times all this squared. Now this term here, it can be written out in the following way: k times and then all this. And so my ODE now becomes this plus this plus this. If I rearrange the terms, I will have this term plus this term plus this term. This one here, that's your F1. This one here, that's your F2. But now look, you have an extra term here. So this expression does not equal F1 plus F2. The addition of two smaller solutions produces something else. It means that the superposition principle does not hold, and your system is nonlinear. As a side note, when you took your first introductory differential equations course at school, I'm sure you remember that when they taught you how to solve linear ODEs of this form, they taught you to first solve this case subject to some initial conditions, x0 and x dot 0. This was called an homogeneous ODE, and it gave you some homogeneous solution, and then you had to solve a non-homogeneous ODE with your external force, but without the initial conditions. That gave you a particular solution, and then your general solution was the sum of your homogeneous and particular solution. If you think about it, you were doing the same thing we've been doing here. You solved the ODE with one input, F1, then with another input, F2, and then you added up the solutions. It's just one of the input forces was 0, and the other one was an actual function. And so you solved these two cases separately, and since the ODE was linear, you could add the solutions up. And then you took your general solution that had some undetermined constants, and you would determine those constants based on your initial conditions. We will have a simple example about it in the differential equations section. So essentially, your system's behavior was dependent on two things: the starting state, in other words, your initial position and velocity values, or initial conditions, and it also depended on the input force acting on the system. Since your ODE was linear, you could solve these two situations separately and simply add up the solutions. You first solved the case where the input forces were absent and you only considered the initial conditions. Then you solved the case where the input forces were present and you did not consider the initial conditions there. And then, thanks to the superposition principle, you could simply add up the solutions to get the total solution. It can only be done with linear ODEs.